this one. Question number 3 point something, yeah. 3.4 we did. We have to start with 4, right?
Yeah.
Okay, so read question 4.
Student investigate the installation
Yeah.
equipment used by the student. This method uses wrap insulating material around the can, put a fixed volume of water in the can, place the lid on top, measure time taken for temperature of water to decrease. Repeat steps 1 to 4 using the same thickness of different insulating materials. Identify the independent variable, dependent variable. The independent variable is the material used,
Yes, exactly. Insulating material. Yeah,
and the dependent is the time taken
exactly.
for temp of water to decrease.
Yes, so independent is the factor that you are changing, and dependent is the factor that you are measuring, which is changing because of what you are changing. Okay, so that's correct. Yeah, independent is material and dependent is time. Okay, let's see 4.2.
What is the resolution of thermometer B?
Yeah,
Is 1.
so the reading given is 87.4, and if you see thermometer, the value changing is the value changes increment of zero point 0.1
Yep.
degree Celsius. So the resolution is zero point 0.1 degree Celsius.
Okay. Thermometer A is most likely to be misread. It's most likely to be misread because if person doesn't read at eye level,
Yeah, if we are viewing angle affects measurement, so which is called parallax error. Okay, when the viewing angle is not parallel, like when we are seeing from above or below, when we are not looking at the same level, that is called parallax error. So
yeah.
viewing angle affects measurement. Next one.
For one type of the insulation materials, temperature of the water decreased from 85 degrees to 65 degrees. The energy transferred from the water was 10.5 kilojoules. Specific capacity of water is 4200 joules per kilogram.
Hmm.
Calculate mass of the water in the can. So you need temp change, energy transfer, specific capacity, and mass. And
Yeah,
so
we have temperature, we have energy, specific heat capacity, we have to calculate mass. So look at the equations sheet and tell me which one you would use.
change in thermal energy equals mass times specific heat capacity times temperature change.
Yes, mass times, yeah, exactly. Now we need mass. So rearrange terms.
1 second.
Okay.
So mass equals change in thermal divided by
Hmm.
specific heat capacity times temp change.
Exactly. Good.
So change in thermal energy,
Check the units.
the 10.5 kilojoules has to be turned into joules.
Yeah, convert it into joules.
Uh, is it times 1,000, or is it
Yes,
times by
it is times
hmm,
1000.
10,500?
Yes, 10,500 because 1 kilojoule is equals to 1000 joule. So yeah, 10,500 then.
So 10,500 divided by
Hmm.
4E200
Yes, 4,200 times.
times 20 degrees.
Yes, 20 because 85 minus 65, 20 degrees. Okay, good.
1 second. 0.125.
Yes, exactly. 0.125 kilograms. Yeah, that's correct. Very good.
Hmm.
Let's look at 4.5 table and try this one.
Table 2 shows the results of two insulating materials. Explain how the results in Table 2 can be used to compare the thermal conductivity of the two materials. So,
Yeah.
material Y is a better insulator
Okay. Yes.
because
Why?
it takes a larger amount of time
Yes,
to
because
freeze.
yeah, it takes longer time for temperature to decrease by 20 degrees compared to material X. So this means material Y is better insulator because it has lower thermal conductivity, right?
Yeah.
So material, did you write the answer?
Yep.
Okay, okay, then we can move
A
to next.
student rubbed a plastic rod with a cloth. The rod became negatively charged and the cloth became positively charged. Explain why the cloth became positively charged. When the cloth rubbed with the rod, the no, the when the cloth became positively charged because the rod took its electrons.
Because of electrons transfer, yeah. So which one is gaining electron and which one is losing?
The cloth is losing and the thing is gaining.
Exactly, exactly. So that's why, because electrons are negatively charged particle, so the one which is losing will become positive, and the one which is gaining negative charge, electrons, they will become that will become negative, right?
Yeah.
Yeah, because there are more positive charge on cloth than negative, so that's why it is positive.
Yeah.
Okay. Now let's look at 5.2.
Explain why the reading on the balance increases on figure 6. Increase the balance increases because when the charged plastic rod is above the negatively charged plastic rod, it
Hmm.
they transfer electrons, or is it a bond?
Yeah,
That's fric.
it is because of electrons.
They transfer electrons. Was it like electrostatic force?
Because both plastic rods are negatively charged. And we know like charges will ripple, right? So the
Yeah.
rod which is held in the hand, it will exert a downward force on the rod resting on the balance. And this downward force, there is a electrostatic force. Electrostatic means because of charge, it pushes the rod on the balance, and that's why it weighs extra. Okay, so the total downward force is one is because of weight, another is because of electrostatic repulsion.
Yep.
There is an additional downward force. Why? Because of the repulsion. Because the same charges repel.
Yep.
Hmm.
Balance at a zero error. The zero error is not important in this experiment. Give the reason why. If the balance is oh, um,
Yeah.
not important.
Why it is not
It's not
important?
because the rods weigh the same,
Yeah, because
but
mass
nothing.
is being observed. We are noting mass. Only the change in reading. Okay. So which allow difference, increase or change. That's why we are already subtracting by to find change.
Yep.
Okay.
A
Let's take
negatively charged
5.4.
a negatively charged rod is held near an earth conductor. Explain why a spark jumps between the negatively charged rod and the earth conductor.
Yeah. So a spark jumps between negatively charged rod and the earthed conductor because of electrostatic discharge. Because there is a large difference in voltage between negatively charged rod and the earth conductor. Because earth conductor is 0 volt and strong electric field will be there between two objects which pulls electron away from air molecule and which make the air into a conductor which make it ions means charge. And once the air becomes conductive, the excess electrons on the rod they will rapidly flow across the gap to the earthed conductor and neutralize the charge which create a visible spark. So it is because of the potential difference between the two objects. Okay.
Yeah.
Yeah, there is a large difference, potential difference.
Figure 8 shows how electricity is supplied to consumers by a national grid. Explain where transformer X is used. Transformer X steps up
Yes, it is a step up transformer. Why it is used?
steps up the is it current or voltage?
It is a potential difference. It
No.
will increase potential difference and it will
Yeah.
because it increases the voltage from the power station before the electricity is transmitted through the overhead cables, and by increasing the voltage the current will reduce, and a lower current reduce the amount of energy which is wasted as heat due to resistance, and this reduce these thermal energy losses, and which make overall transmission of electricity much more efficient because energy which was wasted in the form of heat is reduced and which increase the efficiency, right?
Yeah.
So let me make you write what you have to write.
I did it.
Did you write it?
Yeah.
Okay.
Explain why transformer Y is used in the national grid. Transformer Y steps down the voltage.
Yes, it is. Transformer Y will decrease the potential difference. So for a safer value, it is used, right? Because in transformer, why here? Consumers have to use it here, right? So this is here it will decrease the potential difference. And at X, it has to transfer. And for transfer, energy loss should be minimized. That's why we use transformer up. Got it?
Yeah.
Good. Let's see 6.3.
The town of Hornsdale in Australia has electricity supplied by a huge battery. On one day, the battery transformed 3.24 times 10 to the 11 joules of energy to the town. The potential difference of the town's electricity supply is 230 volts. Calculate charge flow to the town on this day. And then you have to look for the one with charge flow. So, charge flow. Energy transferred equals charge flow times potential difference.
Exactly. This is what we have to use. We need
So,
charge.
charge flow equals energy transferred divided by potential difference.
Yes.
So, 3.24 times 10 to the 11 divided by 230.
Yes.
So 3.24 times 10 to the power 11. 3.24 times 10 to the power 11 divided by 230 equals. I think this is wrong, but 1,408,000,000.
Yeah. So we can convert it into exponent, right? If you are getting a big number, what we can write, it says three significant figures. So 1.41, there are three significant figures, right? We can write it as 10 to the power 9. Like rather than putting 90, we can convert it into scientific notation, right? Remember?
It's 1,408. It's 1,408,695,652.
Yeah, that's correct. Because you have to ignore all those number. It says only write three significant figures. So that's why we write one, two, three figures, okay? And then count how many numbers are there, okay? And then we make
How's
it.
it? How's it 41 though? Wouldn't it just be four?
Okay. So because
You
it
just
is,
round.
see, it is 1.408 like this or something, right? So you will check this digit, okay? After
Yep.
third one, because 1 2 3 it says three significant figure. After 3, if this is greater than 4, if it is 5 or greater than 5, then you add 1 here. So this will become 1.41, okay?
Okay.
Yeah, this is like rounding numbers. If it is less than 5, uh, then you will keep it same. It will be 1.40.
Yep. Uh,
Next one.
alpha particles, beta particles, and gamma rays are types of nuclear radiation. What does an alpha particle consist of?
Yes, alpha particles are made up of.
Radiation.
What type of radiation?
Don't know.
Alpha particles are basically helium nucleus. They have two protons and two neutrons. Okay. So write two protons and they are consist of two protons and two neutrons. Okay.
Yep.
Hmm.
A krypton nucleus decays into rubidium Rb nucleus by emitting a beta particle. Complete the nuclear equation for this decay by writing the missing number in each box.
Yeah, so this is beta decay. In beta, when a beta particle emits, this is called beta decay. So here mass number remains same. So if this is 85, this will remain same 85, okay? But the this will here this will change. Atomic number, it is decreased by 1. So if it is I mean atomic number, it will increase. If this is 36, so this will become you have to add 1 because here 1 is released, so 37. Okay, so atomic number increase by 1 and number remains same. This is mass number. Mass number means number of protons plus number of neutrons, and atomic number means just number of protons. So
Yep.
it will increase by 1 and it will remain same for only beta decay.
Yep.
Remember it. Hmm.
Internal contamination of the human body means radioactive materials inside the human body. Explain how the risk from internal contamination is different to the risk from external irradiation by a source of alpha radiation. Uh,
Yeah,
risk
what do you
from
think?
when
So
you're internal.
the main difference is here of penetrating power. So alpha particles, they have low penetrating power. They can be stopped by a few centimeter of air or the outer layer of dead skin. So that's why external alpha source, they poses a low risk because radiation cannot reach or they cannot damage internal cells or internal organs because their penetrating power is low. So alpha particle, they have low penetrating power, so they will not you know uh, they cannot reach our internal organ. Penetrating, because of low penetrating power. So if an alpha source is inhaled or it is swallowed, it is in direct contact with living tissue. Alpha radiation is highly ionizing, so it means it can cause damage to DNA, it can cause damage to cells. But this, when it is eh, when it is like inhaled, then there is a high risk of causing mutation in DNA. It can cause cell death, it can cause cancer, because there is no protective skin barrier to block these particles. Okay,
Yeah.
so if it is externally there is a low risk, but if it is there is a high risk when we inhale it or swallow it. When it comes in internal direct contact, it can cause cell death, it can cause cancer, it can cause mutation in DNA. Okay,
Yeah.
did you get it?
Yeah.
Okay, did you write in your own words?
Yeah.
Tell me what you wrote.
When inside, it can cause mutations inside and cause cancer, but externally low risk as cannot mutate cells or kill cells because it's alpha radiation, but beta,
Because of
no.
low penetrating power.
Yeah.
For external radiation will not affect it because of low penetrating power, but internal contamination will be very dangerous
Yeah.
because there is no boundary or anything to protect ourselves from it. Okay, let's do number 8.
Student determine the specific latent heat of vaporization of water. Figure 9 shows the equipment used. This method used 50 centimeters water in a beaker. Measure the mass of the beaker in water. Use heater to boil the water and keep it boiling for 600 seconds. Measure the mass of the beaker and water after 600 seconds. What measuring instrument should be used to measure the volume of the measuring cylinder?
Yeah, what instrument we use to measure volume of water?
Measuring cylinder.
Exactly. So just write measuring cylinder.
What is the hazard insurance investigation? Boiling water.
Yes, boiling water. Good.
The initial mass of the beaker and water was 0.80 kg. Final mass of the beaker was 0.071 kg. Energy transferred in by immersion. The heater was boiled by 25,200 joules. Calculate specific latent heat.
Hmm.
So specific latent heat. Mm, specific latent heat.
Initial mass.
Specific latent heat. 1 second.
Okay.
Mm, specifically. Mm, oh, thermal energy change of state
Okay. Is equals to?
equals mass times specific latent heat.
Yes.
So specific latent heat equals thermal energy change divided
Yeah.
by mass.
Yes, yes. Yeah, exactly. That's wrong.
So 25,200
Yes.
divided, do you do the change in mass by
Hmm.
0.009?
Yes, yeah. If you subtract them, you will get final minus initial 0.009. Yeah.
25,200 divided by 0.009 equals 2.8 million.
2.8 million.
Yeah.
Um, two, yeah, 2.8 million. Okay, that's correct.
So 2.8 million specific heat and latent heat of vaporization unit is kilograms disease degrees.
Joule per
Mm.
per kilogram.
Is that it? Or is it no degrees thing?
No, joule per kg. That's it.
Some thermal energy was transferred to the surroundings while the water was being heated. Explain how this affected the student's value for specific latent heat of vaporization of water. It changed it and made it less accurate because some was lost to surrounding.
Um, yeah, because if energy is lost to the surrounding, not all the energy measured by the heater is actually used to vaporize the water, right? So the effect will be the calculated value for specific latent heat will be too high. because the value used for energy in the calculation is larger than the energy that actually went into changing the state of water, since the latent heat and like an overestimation of energy lead to overestimation of thermal energy, right?
Yes.
Yeah.
Some of the water evaporated before its temperature reached 100 degrees. Explain how this affected the student's value for the specific latent heat of vaporization of water.
Yeah.
It decreased it.
um okay, because if water evaporates before the timing, before the measurement of latent heat begins, due to natural evaporation rather than the heater, it will affect the mass reading, because the calculated value of specific latent heat will be too low, because the measured change in mass will be larger than the mass actually evaporated by the heater's energy alone, right?
Uh,
So the measured change in mass is too high for the energy supplied, and students' value of latent heat is too low.
okay.
Did you write or should I write it?
Wrote
Okay.
A figure 10 shows a girl doing an experiment to determine her power output running to the top of some stairs. The mass of the girl was 60 kilograms. The height of the stairs was 175 centimeters. Girl ran to the top of the stairs in 1.4 seconds. Gravitational field strength equals 9.8 newtons per kilograms. Calculate power output of the girl using mass, height, time, and gravitational field strength. Gravitational potential energy equals mass times gravitational field strength times height.
Yeah,
Mm,
this will give you weight, right? Mass times gravity times height.
um,
I mean, work done.
GPE equals mass times GFS times height. Um, so mass is 60 kilograms
Hmm.
times 9.8 times
Yes.
100. Do I have to put 175 centimeters in meters?
Yes. Convert it into meters.
175 centimeters equals 1.75 meters.
Yes.
So 60 times 9.8 times 1.75. What wait, do I have to convert kilograms to grams or
No,
okay?
that's fine. That's the standard.
1020 1029 equals
Yeah.
gra equals
This.
GPE. That's gravitational potential energy. But to
Yes.
find power output, you have to do, well, to find power, you do energy transfer divided by time.
Yes. Exactly.
So power equals 1029 divided by 1.4
Yes. Exactly.
equals 735 watts.
Very good. Absolutely correct. This is good.
Total power output of the girl was greater than the answer to question 0.9.1. So just two reasons why. Um,
Yeah. Whenever this
Uh,
type of question
some
is there,
some
hmm, yeah, yeah,
some energy is lost to surroundings.
exactly. Some energy is wasted to surrounding because girl increases her kinetic energy as well as increasing her gravitational potential energy. So some energy is wasted in our muscles, some energy is wasted as thermal energy to surrounding. Okay.
Yep.
Hmm. Next.
What was the second reason? I did the first reason is some energy is wasted to surrounding.
Okay. um so you can write it. uh, Girl increases her kinetic energy as well as increases her gravitational potential energy.
Yep.
Done.
That. Yeah.
Okay,
A
let's
boy
read
took more
this.
than a boy took more than 1.4 seconds to run up the same stairs. Power output of the boy was the same as the power output of the girl. What conclusion could be made about the boy's mass? The boy's mass was greater than the girl's mass.
Yes, exactly, because we know the formula power is mgh over t, right?
Yeah.
Yeah, so um that means the boy took more time than the girl to complete the climb. So if the mass is more.
Figure 11 shows a student launching a toy airplane. Just before the toy airplane is released, the spring has an extension of 0.12 meters. The mass of the airplane is 0.20 kg. The spring constant of the spring is 50 newton meters. Calculate maximum speed of the toy airplane just after it launched. And then use you try and speed. Um, maximum speed.
Hmm.
Um, Expedia. Distance traveled equals speed times time.
um
So there's two equations though.
yeah, we
So
need to use. So
distance. So distance traveled equals speed times time.
no. See, first you need energy because see what is happening here first is because he is using the spring. So first we calculate elastic potential energy, and we know the formula for elastic potential energy is half constant E square extension square. Now we have when we have energy after this because the movement is happening, because of that there is kinetic energy, and formula for kinetic energy is half mass times speed square, and from here we can find speed because we have this energy which we will plug here, right? And we have mass given here, right?
Um, what do you do first?
First we, because of the spring there is elastic potential energy. So what is the formula for elastic potential energy?
0.5 times spring constant
Hmm.
times extension squared.
Yeah, use it and find that
So
formula.
extension is zero. Yeah, 0.12 meters squared. And spring constant is 50.
Hmm.
And then so 0.5. 0.5 times 50 times 0.12 squared equals 0.36.
Yes, 0.36 joule is the energy. Now use kinetic energy because here it is talking
Then
about speed.
kinetic energy equals 0.5 times mass times speed squared.
Yeah, now find speed from here.
To find speed, what? Speed squared equals kinetic energy divided by 0.5 times mass.
Yes, exactly. And then you will square root, right?
1 sec. Divided by 0.5 times mass. So the mass is 0.0020 kilograms. So the kinetic
Is 0.36. The energy that we just calculated, the same energy is transferred in like transformed into kinetic. Okay, so we'll use the same value,
okay.
point.
So 0.36 divided by 0.5 times 0.020
Yes.
equals 0.0144
Is that your answer?
miles. Yeah. No.
Mm,
Oh. After it. So root 0.0144 equals 0.12.
no.
Um,
Did you get this equation? 0.36 over 0.5 times 0.020.
and then 0.36 divided by 0.5 times 0.020
Yeah.
root so root then 0.36 divided by 0.5 times 0.020 equals 6.
Yes. So the answer is 6 and it is speed. So what is the unit of speed?
Miles per hour.
Meters per second. Okay.
Complete the sentence. As the airplane moves upwards towards the air, there is a decrease in the as the airplane moves upwards through the air, there's a decrease in the. Isn't there an increase in gravitational potential energy?
Yeah, and decrease in what?
Elastic.
Kinetic, right?
Oh.
Because as the object gains height, it's gravitational, but as it increases speed, it's kinetic.
Give one factor which would increase the distance the toy airplane travels horizontally before hitting the ground. The weight of it.
Uh, by weight,
The weight of the airplane.
by reducing it or increasing it, or what? What would
Uh,
increase the horizontal distance?
reducing the weight.
Yes, reducing the mass. Okay.
Uh, Figure 12 shows some hair straighteners. Hair straighteners contain heating elements. When the hair straighteners reach normal operating temperature, an LED turns on. Draw the circuit symbol for an LED in the box. Light emitting detector. LED.
Yeah, so the symbol is like this, this, and there is a
And
circle.
then there's
And
arrows.
yeah, arrows like this. This is the symbol for LEDs.
Figure 13 shows a circuit diagram for the hair straighteners. Each resistor represents a heating element. Power output of the hair straighteners can be changed by closing different switches. Why do the hair straighteners not turn on when the only switch is closed? Doesn't turn on because the current, the other switches are open, so circuit's not complete.
Yes, because S1 and only S2 is closed, right? I mean,
Yeah.
this only this part are closed and they are not closed. So yeah, it is incomplete circuit. Okay, because switch is open. So
The hair
current will not flow.
straighteners have a maximum power output of 120 watts. The energy transfer of the hair straighteners to reach normal operating temperature is 3.6 kilojoules. Calculate the time taken with the hair straighteners to reach normal operating temperature when operating at maximum power. So 3.6 kilojoules to joules is 3.6 million joules.
Not millionth. You just times it with 1,000.
Oh, so 3,600.
Yes, 3,600 joule. Yeah.
3,600 joules, and then use power output. So you want calculate time. So time, 1 second, time. Energy transferred equals power times time.
Yes. Okay. That is
So
correct.
time. So energy transferred equals power times time. So time equals energy transfer divided by power.
Yes,
So
that's correct.
3,600 divided by 120. So
Yes.
36. It's 30 seconds.
Very good. Yeah, it is 30 seconds. Absolutely correct.
Figure 14 shows the hair straightening circuit with switch 1 closed. Switch 2 and switch 3 are then closed at the same time. Explain what happens to the power output of the power supply. The power output is then shared throughout the circuit.
Um, okay. Because when switches S2 and S3 are closed at the same time, total resistance will decrease by adding more parallel branches because they are parallelly connected, right? Parallelly
Um,
means in branches like this. They are not in series, in a line. So by adding more branches means resistance is decreasing. So
yeah,
if resistance decreases, the current will increase, right? Which will
yeah,
increase the power output in which will increase the power output. Yeah.
yeah.
So this is what will happen to power supply.
Okay. Right. That's the
Oh, that's the last question. We are done with this paper.
yeah.
Okay, can you send me the other one? We have time, we can do.